you are neighbor from where Daniel Yamins used to live for many, many years. I think he's now not there, but he's in Oxford Street. And
Really?
that house in Denver was like exactly that.
Oh,
Beautiful. So anyhow, I love that street and all the neighborhood.
if you
So
guys come to
congratulations on your new house.
Boston, if you guys come to visit,
I will love.
we have a
Well, I'm
room
the same.
upstairs, the playroom, and it has a bathroom. So,
Fantastic. And here we have this small bedroom that is going to be my mother's bedroom. It's not very pretty now, but if you are guys coming
she's
to
coming.
Barcelona,
Oh my God!
she's
Excellent.
coming in 9 days. So, whew. Okay. Now, back to business.
Okay.
So I read the email, Julian.
Yes.
I think it's a fantastic plan of action. I'm super happy that you are so organized and structured. And that makes me, really inspires me, because I was talking with Javier, like, okay, we can do this once, but I don't think we can do it twice with the next person to train. So I feel a lot of trust passing the torch to the two of you. I'm super happy with these meetings and really happy how things are going. So, remind me again, last week we managed to create the ROIs from the pharynx.
Mm-hmm.
And we had just seen the result, but we didn't discuss what was each thing. Is that right?
That's right. And I looked through some of them since the last meeting, and we were talking about how, sometimes some of the dark spaces are inside the outline of the pharynx, and that's good.
Right.
But
Okay.
as we looked through them, there were a bunch that, they were like donuts. They had little bits left out.
Yeah.
So those we have to
Okay.
fix.
So we have to check that. So how do I share my screen here?
Yes, it's on the left side. There
Is
should
the
be
pink screen share? Good.
the green one.
Fantastic. And I can only share the. That's great. Let me see this. Screen share.
Oh, you have to share the entire screen.
Okay.
It can't just do image J because it's
Yeah.
multiple
So I
windows.
was thinking whether we could share image. But desktop. All right. So now I'm seeing your desktop, Julian, I think.
Oh, you're seeing mine?
I saw
see
more.
I see a recursive thing. I don't know what happened.
Yeah, I think that's. Let's see.
I think that's yours.
Uh-oh.
I think you're broadcasting what we showed you, and
So let
Yeah,
me
you
try
have
again.
to whenever you broadcast your screen, you have to minimize the Hangout, so you'll only see your screen, but we'll see yours.
I see. But I am trying to share my desktop. I see.
There we go. Now I see your desktop.
Excellent. Awesome. So let's try again from what we did last time. Basically, this is the threshold at 2000, and we're going to run the threshold particles.
And I'm getting everything set up on my screen right now.
Awesome.
I have to run. I don't run the subtraction first. I just go ahead and do the particles, right? Or just.
Say it again?
I don't need to do the subtraction before this, or I do?
No, well, if you see, I am opening already the file that doesn't start by the C1. So this is already subtracted. And the way to check it is you just stand in the background, and the values are very close to 0. So
I'll go ahead and open my subtracted ones.
Exactly.
Here's my 410, here's my 470, and they're both subtracted. Or do I just open one of them?
I do the segmentation at 410.
410.
Now the intensities are very similar. So if you remember, the ratios were close to 1, 1.1. We did in the past some controls to see how different was the segmentation at 470, and we decided just to go with 410. But that's an historical decision. I think you can change it if you want to focus on 470.
I think the main reason for that decision is that the 410 images don't change that much with an oxidizing reduced and the 470 gets really dim when things are oxidizing, so they're not very good for segmenting sometimes.
That is totally right. That's true. And indeed,
so I'll show you my screen to make sure I'm doing it right.
Mm-hmm.
Here we go.
Let's see.
Oh, that was very cool, by the way. The
recursive thing.
Another fact that we can switch screens like this.
But now I cannot see. I'm seeing the recursive thing.
I'm seeing. Oh yeah, I see that in your screen. Can you stop broadcasting, Kata?
Yeah, I will try. Okay, I stopped.
And now you should see my screen, yeah?
I see now. All right, I see you still in. Wait a second. Which threshold are you applying there? Okay, so you are at 3600. I see.
Oh, that's not that.
If you're stopping there, exactly, that's right. Okay. Let's see. So what I'm seeing there is the outline was defined at a threshold of 2000, but the thresholding value that you have right now is slightly higher. So you are seeing these dark areas.
So should I try to rerun it? I can cancel out and try it again.
No, I think this one is good. What you can do is go to the threshold window and push the set button.
Okay.
And then you'll find that instead of 3611, you want the lower one is exactly 200,000. So, Julian, just for you, for historical reasons, the camera of the microscope, the maximum value is around 16,000. It's a 14
minus 1.
Minus 1, exactly, because it's the 0. So it's a 14-byte camera. However, we decided to put the upper limit to all the imaging analysis to a higher value. And the reason is that while we were calibrating the sensor, we're doing some experiments where we will do shorter or longer exposure times and do a flip of the linear exposure time. So Javier will explain that later to you, I'm sure. But just for you to know that 60,000 upper boundary is an artificial one. Our camera doesn't get there.
Okay.
Little details to notice. Awesome. So you have there the ROIs, and if you go, normally what I would do is exactly what you are doing, is scrolling one by one, checking very quickly their quality.
Okay.
And
all of these look good so far.
Yeah, you mentioned there were some donuts.
I thought I saw some, but maybe I was looking at the wrong. Oh, here's one. Oh no, not quite.
But a little, you see a little dent.
Yeah, and a little dent here too.
Exactly. So, in general, for the average of the pharynx, those dents don't matter. Okay. They become important once you start defining the profile of the tissue, the anterior posterior profile. Yeah, like that dent there, exactly. Which is the width of that? Can you make bigger the
image? Oh, that's not what I wanted.
But that's cool.
Yeah.
That's how we learn. If you think, I think Command plus, exactly. Look at that. So that dent will give you only a measurement. The width of the region you are including is 2 pixels instead of 4. So that's the case, that type of cases you want to avoid, because basically, again, for the average tissue it doesn't matter, but for the profile you will be passing a very thin line scan, along the middle of the tissue.
Mhm.
And then what you will have in that case is that some of the pixels are, because they are not included, you will understand better later, depending on what we do with the pharynxes. But basically, the ROIs are right now in any orientation and in any angle. So the next step of the image processing is to take the ROI and copy it into a vacuum stack where you have no background, no other values. It's totally artificial, but you are only focusing in centering and aligning in the anterior-posterior axis, the pharynxes.
Okay, so what do I do now here?
Right now, for that individual ROI, so you are stepping in 76. Is that correct?
This is 70, I believe.
That's 70. Okay. So what I would do is you go to threshold.
Threshold, good.
And lower slightly the threshold value to 1900 probably, until you include those pixels. Right.
Okay, so I can do a set here. And do
Yeah.
1900. And that's a little bit better, I guess.
But not much. Try 1800. That's better. Well, I cannot see very well from my screen, but you will decide whether they're filled or not.
So what am I trying? I'm just trying to fill the outline completely?
You are trying to fill, yes, to include all the isthmus of the pharynx. And exactly, that will be good enough.
Okay. So then I leave it like that and it stays like that for this image?
Yeah, and I'm going to let me go through where I have my macros, because I'm going to pass you a little macro that I did for correcting this type of cases, but I need to find it. So,
and I can copy the macro if you show it to me, if that's easier.
Yeah. Okay, alignment contrast. Not finding. 1 second. Okay, I think it's this one. It has a very funny name. Let's call it in a different way. All right, let's see if this will run. But I'll put it in. So right now we have, I'm going to create a macros folder
In
and put it
Dropbox?
there. So it's extremely simple. It is back. Save. And save. And it's basically 3 lines. And this is going to be called replacing ROI.
Accordion, restore selection, and update.
Replacing ROI, exactly. So there's this command that allows you to, once you are standing in an ROI, let me see, I'm going to go right now in my screen to that region. It was number 70, correct?
Number 70, there you go. So
Okay.
I'll run the macro.
Right. So let me see if this macro actually does all the steps that I think it does, but I'm not sure. So
it moved my outline here.
So macro. No, there's something that is not working here. Let's see. Macro, replacing ROI.
Placing RI, so I can try to run that one.
But also, I was wanting to show you to play with this word.
That one didn't do anything.
I'm not very happy with the boundary of the threshold set. So if you look to my screen right now,
Okay. It looks like you haven't shared it for me though.
let me share it again, sorry. So this is me, and I share this one. Let me know when you see it.
I see it.
Yeah.
So instead of going to a set that takes a little time to decide the value and type it out, I just scroll the lower part of this bar until I
Down
am.
there at 400. See, mine's different right now though because I ran that macro and this is what it did to me. It did here, did this.
Let's see. Like this. So I see. Wait. Okay. So I'm starting to look. Oh, that's an outline outside the pharynx.
Yeah, that happened when I ran the macro that you sent me.
Go to ROI 69, please.
269. There we go.
Huh. You see what is happening?
No.
So basically, that macro that I sent you is for a totally different purpose.
Oh, okay.
That is to remember an outline and to replace it in the current stack that you are.
Oh, okay.
So take away that macro. That
How do
one is
I reverse
extremely
it?
useful. I'll tell you when you will use it. We're doing this experiment that we're time series.
The macro that you sent him is the one that you use when you are drawing something over to manually create like a region of interest with a new threshold, and then you want to transfer into a new stack. Is that correct?
No,
That
not
what you
even.
said?
That macro corresponded to experiments when we were doing the time series of 30 seconds exposition in interbutyl peroxide. So Julian, we will doing this stress experiment where we will have a whole hour recording of a worm exposed to an oxidizing medium. So it was 120 time points, from which the autofluorescence of the gut was okay until some point that will start increasing. So manually you will have to exclude the gut in each element, but because the worm was immobilized and was such a long, this macro basically define one correct outline and then will ignore the other automatic outlines that will start including the gut and pasting this on top. Javier, do you remember this?
Well, we had. I remember the experiment.
Yeah, exactly. So it's basically for time series. That's the only thing you need to remember. And basically, around after 10 minutes in interbutyl peroxide, the autofluorescence of the gut will start being included. So as long as the worm was not moving between time points, you could just replace them. And you could add a loop of that, saying like replace it in the next 21 frames, not in the 22nd, and then define a new one, and so on. Okay, never mind. Forget about that. let me see. So basically, what you can do here is store selection. Let me see again in my collection of of macros, which was the one, because basically the one that I'm having in mind was simply erases that outline without erasing the thresholding, determines a new outline with a lower thresholding, and goes to the ROI and says, replace this outline by the one with lower. So we can also do it manually now, and I can look, instead of spending valuable time right now, we can just, I can look for it later and send it to you. Just let me give it one more try.
Yeah, that seems like a good idea.
Yeah, I think so. Okay, so I'll show you right now how to do it manually. And maybe if you want in your screen, just start recording, and you will see which are the values I get. So I will start again sharing my screen. Are you seeing right now my screen?
Yeah, I'm clear. I was looking for something for my voice.
Okay.
I don't know how.
Okay, let me know when you guys are ready.
I'm
I'm
ready.
ready.
Okay, perfect. So to the element, record. This is how you do this, and then we stand in the slide where we want to replace the ROI. Hit Command Shift A. That command means select none. So basically, I deselected the pixels that I have selected before. And then I go to the most unintuitive process. It has a way to define regions that is a bit weird. You go to the edit menu. Go to selection. And then create selection. Is there any delay with the handouts, or are you guys in the same page?
I'm good.
Okay.
I just clicked create selection. Yeah.
Great. So then you go to the ROI manager and hit replace. Where is replace here? Update. Sorry, update.
Oh, add.
Update. Yeah. So if you add it, you will get an extra ROI, but it will keep the previous one as well. So you will have 2 of slice 70. If you update, it will just replace this one. So for the next one, we'll use add as well for you to see. Okay, so this is a stop recording.
And there's my macro.
Yeah.
I'll save that.
Right. So basically, with only these with these 3 commands, you will create a new macro for yourself. Or, again, this is all like manual curation or going by one by one. However, if you start seeing several of those cases in the whole stack, let's see if we find any other with a denture. If you find those cases, in more than one slide, what I will do is to ignore this set of ROIs and go lower through the threshold. So in worm 1 to 9, we see another case where we have a little inlet.
See, on mine it's fine right now though for 129.
Which threshold are you in?
I'm from 2,000 to 60,000.
From 2,000. So I am, let me put 2,000.
But it's to 60,000.
Wait a second, 2,000 to 60,000. It's not updating. There's something wrong with, and these things happen sometimes in the set. Should be doing this in command line.
That's weird.
It is weird.
See, mine is like this. If you want to see, but
Wait a second before you share my screen. So, I see. Basically for this one. So, which is the next worm for you, Julian, where you have one of these problems of some pixels being excluded?
let's see. That's what I'm looking for right now. Probably 170. Has a little bit.
Yeah, but it's not. It's like inside. It's like an island.
You see on the interior end, right? Like there's a little rectangle.
I see. I see. For some reasons that basically when we talk about the profile, that wouldn't matter because we assign more value basically to the proportions of the pharynxes. Basically, independently of the length of the pharynx, they will all get normalized to 100 pixels. And the first 2 pixels, they will be thrown away because we have less confidence in their values, and one of the reasons is exactly this issue.
Okay.
So right now I will continue scrolling, just looking for the cases inside the isthmus. And again, I'm talking about the isthmus, but I don't know if you're familiar with the morphology. We're talking about this bridge between the two balls.
Okay, isthmus, just like a geographical isthmus.
Exactly.
Like the Isthmus of Panama.
Precisely. So 224 is a little thin.
224. Okay.
So we found already two of those cases that we're unhappy with. So what the next thing I will do, if I find 2 or 3, is close this ROI and the tables.
Okay.
And said, do you know what? Actually, for this experiment, we want a little lower threshold. So we go, I usually find the right threshold between 1200 and 2000 for young individuals. Let's say for individuals between day 1 and day 4 or 6. Let's try now with the lower one. That is, usually I don't go any lower than that 1200. It will have to be something very unusual. And before running again any redefinitions of the ROIs, you can just scroll around and see if you are including any ugly points of the gut. For instance, there's a worm. I passed one with like 111 has a couple of pixels that are separated. Do you see what I'm saying?
It's yeah, towards the
right.
posterior end, you have like a little spray of pixels.
Those are totally okay. The important thing is that they are not connected, and the reason that is okay is because in your ROI file you have one condition, and is that any region that is below size 200 will not be included.
Okay. Cool.
So it has to be sized between 200 pixels and infinity. So fine. However, if you have any pixel of the gut, like that is contiguous to the pharynx, then it's a problem. But let's say this is a bit ugly, like worm 29 already has too many pixels included, but let's run it right now with that lower threshold to see what happens. So again, I save and reinstall my macros, otherwise it will not update this page of 1200. And then we will run a threshold of particles. Right. Let's see what we get. So you see that, okay, let's just to contrast how different are the two thresholds. Let's go back and show me in the image the 2000. So in here, what we are seeing right now in this image is an outline defined at 1200 versus the red area that shows you 2000. So as you can see, the difference is really minimal for these pharynx. And it's mainly, it's not even whole pixels, sometimes it's the diagonal pixels or just one row of pixels.
Wait,
So
it's the other way around, right? The outline is defined at 1200.
Yeah, that's what I said,
Okay.
I think. The outline is at 1200, so it's a little bit bigger than the threshold.
Yeah.
But for instance, this was the worm that we were seeing last time. Let's go to worm 70. That was the first one we were dealing with tonight. And yeah, so you see in worm 70 now, you have no problems with that region, but the pharynx is a little bigger.
And for some reason, my 70 looks a lot better than yours. I don't know why. I don't know why that happened. I did the same thing you did.
Yes. And let's compare something. Go to slice 70. Oh, we have to close the table.
Okay.
Go to slide 70 and hit Command M.
Command M.
That is measure.
Okay.
Which is the value you see for mean?
5,211.
Okay, so we do have a difference in the images. My mean is 5,126.
Mm-hmm.
And your standard deviation, just to not...
About 3,000.
Okay, minus, yeah, 2,059. So we are actually dealing with different images. And you open the 410 subtracted, correct?
Let's look at Julian's screen.
Yeah, that's my problem. I opened the wrong one, so I'm gonna fix it now.
Were you opening the 410, 470?
I was opening the unsubtracted one.
Oh, fantastic! Good news.
Good
so
news.
That's exactly why this is perfect example of why I like saving the images after each step with the different suffixes or different file names.
Because if not, then I wouldn't know that this was the unsubtracted one.
Exactly. Or you can just not notice unless you step in a zero value and like, okay. Right.
All right. So now I'm running mine.
Awesome.
Okay, just finished, and I'm going to 70, right?
Yeah, or better go to 224. I'm just scrolling very fast to see.
You say 234?
224.
224. Okay.
Yeah, that's better.
Okay, so.
And now I command M to see?
Yeah.
Alright.
And your mean, please?
Oh, it's, let's see, it's not coming up. Okay.
Do you have the table of all the measurements open?
Yes.
So then it should be the last measurement in that table.
Oh, okay, here we go. Yeah, so my mean is now 5596. Yep,
Excellent.
It's the same as yours.
That's right. Awesome.
Okay.
So just as you can see, you have plenty of room to play with the lower threshold. The important part is first of all, checking that through all your stack is okay, and you will very quickly develop an eye, like to do that in few seconds. But also, these changes, like for instance, deciding for the 1200 instead of the 2000, it will increase marginally the area of the tissue, and it will lower marginally the average intensity. But in terms of the ratio, has very little effect. So as long as you are happy with overall the morphology of the tissue, and particularly the isthmus, that is the trickiest one for the anterior-posterior profile, you are safe.
And if I'm not happy with it, I just change the threshold.
Exactly. So let's see how long it will take. Basically, manually you will stand here, go to a threshold window, change a little bit here. I will be happier with this one. Then go Command A, and then go to Edit, Create Selection, Create, and you update. So it's few seconds, but obviously I prefer to have just the least manual interventions, just to make it more unbiased, but also for your sanity, because when you have to do 6,000, when you know you have 6,000 images to
look at.
It's like just not elegant enough. So I would be very happy with this level of thresholding for the whole rest of the stack, I think. Well, let me go through the whole rest of it.
Because I'm at 1200 right now for the whole stack.
I am at 1300, that's true. So
See, I see things like this. Here, I'll share my screen here. Present to everyone. I see this little grouping on the back.
But you see that has not a yellow outline?
Yes.
So that is not considered for the measurement.
Okay.
So what is great of these ROIs is that you define which is the region of interest, and all the rest falls into something unattended. You will ignore the rest of the pixels. So that you have right now is a good one. That's slightly ugly. It's not terrible. But as you can see, yeah, make bigger that the image. Yeah. So that one is problematic. You stand in the outline, you will see that there is some pixels that might be part of the gut at the very edge. So what I will do is, am I sharing my screen right now?
I see Julian's.
Okay.
Now you should see Catalina's.
Okay, so in that was 275.
That's it.
Again, I will go to threshold to 2000. Okay. And just very quickly erase this outline and create selection. Again, I have a little macro that contains these two steps, but I will look for it, write down so that I don't remember. I forget.
But that's an easy
But the idea of recording your actions to see what the language is very helpful, because this is not. We should be able to recreate that macro.
Absolutely.
But you did.
You can.
Yeah. I mean, that was pretty straightforward. So.
Right.
Yeah, I think I already have that macro written down here.
Perfect. So I will look for it. So what is exciting of having the perfect set of ROIs is that now, right now you have been dealing with a lot of pixels per image, from which you are interested only in few. So the next step, what it does, is just throw away all the information of the rest of pixels and just focus in the region of interest.
Okay.
And you are going to virtually take those pixels and paste it in a different stack. Rotate the ROI or the tissue so that are all aligned in the x-axis, and then flip it in the anterior posterior direction. So that simplifies enormously whatever you're going to do mathematically, because now they're all in the same angle and with the same orientation. Before we get there, we need to save the output of this last step. So once you have the perfect sets of ROIs, it's super important to remember to save all of them. If you hit save, that is inside more, it will only save you one ROI, like the one of slice 417. So you don't want to get that. So always remember to select a particular ROI where you are, and then you hit save. And what I used to do is to set ROI, and finally this we did it at a threshold of 1200. So basically, even if you did some manual changes, choose to save in the file name with the threshold that you use for the majority. And once you have this ROI manager closed, it's great. You can just can import to ImageJ, and you will get all the outlinks. So this is pretty essential to save.
Okay.
Perfect. Once you save it, you want to extract which are the measurements of these ROIs. So the ROI basically defines the measurement, average measurement of the tissue. So we can hit measure, and again will give us a table that is 417 rows, like the number of slices you have. And the number of columns had been predefined in this macro that we have. We were predefining it with this line of.
And that's what we predefined it in every macro. We have that same definition.
Exactly, and that's because I am basically neurotic. Because sometimes you're playing, and what you can do is you are playing with measuring different things when you are establishing your pipeline, and you decided to do, I don't know, few of these. You change manually this, and then you continue doing this, and as you can see now, the table has a different number of columns.
Mm-hmm.
So what I hate is that independently of what I change, I make this macro basically foolproof. Independently of what you manage to change while you are exploring the images or checking to experiment, I prefer to redefine it every time I run it, so that I don't have to check the number of columns in each table, and just import it to either MATLAB or to JUMP. That's a good point, Javier. Do you guys have license of JUMP?
Yes,
to JUMP?
we have MATLAB.
And JUMP?
Yes.
Okay, because I like many of the exploratory analysis that you can do in JUMP. And
well, we don't have his DNA on LaserGene, believe it or not. I'm working on getting something.
No! Now you don't need it, Javier. Go to Benchling. I'll send you a couple of, well, the one, Kiagin has a package for plasmid sequencing, alignments, everything that DNA does. I was considering buying it here.
Which
but
one?
The prices are not justifiable. I'll send you an email with the ones I like the best.
Oh, good.
They're called CLC, and there is one that is online and is fantastic to share documents between colleagues, and it's called Benchling.
Yeah, I know. CLC is one of them, and the other one that I'm looking at is called uh, Genome Compiler.
Genome Compiler, I wasn't very impressed with it. The one I was very happy with was this one,
Okay.
BenchLink. Do you see it in my screen?
BenchLink.
Yeah.
Okay.
It has a lot of the spirit of Dropbox in terms of sharing. You can open it from wherever, but it's really very smart in terms of the display, has all the Gibson cloning, a CRISPR design, etc. It's really up to date. And
Okay,
it's
and
free.
is it freeware or is it the license or?
No, it's free. You open an account.
Really?
And, yeah. I was very. It took me a while to find which was the cheaper, and then Lorena, this technician that will be working with me during my maternity leave. Yeah. Okay. Good. So, coming back to the average tissue, this table of measurements is the output of this step of the analysis. So. Wait a second, this looks weird.
Yours look weird.
It's because I updated one of the lines that was outside my macro. So now I go to subtract mode, threshold particles, and run set measurements. Okay, I was running the set measurements that I take for the morphology. And that will talk another occasion. But okay, now we're back to area, mean, standard deviation, etc. So a few things you might want to do at the beginning is just to check the number of rows, to check that you didn't have any added ROI. Because what happens is that, let's say that I'm standing in this one, and let's see if I hit add, and then sort the ROIs, I will have two ROIs that correspond to the slide number 2. Mm-hmm. Do you see what I mean?
Yes.
So in this case, both are identical and it's just a duplicate data set. But from now on...
what are the second and third columns?
Wait a second, and I delete this one. Of the measurement table? Okay. So basically you have the number of the slides, and then I think it creates, although it doesn't make sense here, it has a nomenclature of the X and Y, I thought.
Oh.
No, it's not that. These two numbers corresponded to other identifiers of how this outline was selected. So one of them I thought was like a bound box. Yeah, right now I don't remember exactly what do they mean, but they don't bear much information. I mean, that I use for other people maybe, but so basically other things in the ROI manager that are useful is the add and delete button. It's obvious, the measure for sure. The flatten, I have never used it, and in more you will find the save. All these combinatorial like and or we won't use them because you will only want to have one ROI per slice. So, and I think that's pretty much it. So back to the table. This output is very important because this table will give you the values of the average tissue. So I save it with the same name of the image we are analyzing. So in this case is the subtracted 410. But instead of finishing with TIFF, it finishes in TXT. Now when I hit save, it will ask me, really, you don't want to use Excel? And the answer is no. In general, for research, you do not want to use Excel no matter what. So the TXT can be imported to the majority of softwares that you will be using for like statistical analysis or MATLAB. So just anything that is numbers, save it in TXT, and anything that is files, I prefer the TIFF. Other people uses different extensions, but for this simple analysis, we don't need any fancy compression. So TIFF is good. Okay, so you're pretty safe because now you have the intermediate tool that allow you to define the outlines and the numeric output of the outline safe. So you can close this one. However, you need the result windows open because this table is going to be one of the input of the next macro.
Okay.
So let's try next macro, that is the ROI to stack. Let's try to figure out what it does, and basically I'll run few commands. Okay, I'll need to run few chunks.
The ROI only works if ROI Manager isn't open.
No, actually, I think that the ROI Manager can be open. I just, as an habit, close all the windows that are not going to be used anymore. But I think it can.
The top part is commented then. You did the slashes.
Ah, okay. Yes.
If not is open, ROI Manager.
Yeah. So here. That's interesting. Thank you for noticing that. So basically, I was trying to with these extra lines, like warnings or like the macro not to run if I was not standing in this result window. So basically, yeah, these two lines, now I don't use them anymore. But all the things, I think it can be open. Let's run it now, but I think the only thing you need is to be standing into the result window.
That was my mistake, because the code says only not do it if both of them are closed. So you just need one of them open.
Okay. Right. So let's, shall I run it all? No, let's go by pieces. So I run these shaded first lines, which basically is a way to create a file, a new stack, that instead of having 174 times 130 pixels, have 100 by 100. And has a bit depth undefined, the name is ROI stack, etc. And then what I'm going to do is to run a loop where I go for each row of the table, I go to a variable angle, extract this number, and then select that region. Actually, I think I need the. Oh, let's see. Select that region, paste in this new image, rotate it by the variable angle for each row,
which we just defined,
and then go to the next one. So let's run now the whole macro, see how it goes. So it's ROI to stack, and this is the slowest part.
I have an error.
You have an error. What does it say?
I just presented.
Let me stop this one so that I can look to your screen. So, excuse me. It says index 0 is outside the 0 and 1 range in lane 73. Our manager. So I don't know which is the. Okay. Look to your ROI manager. Right now it's empty. So you're asking it to go to the first ROI, but you have a 0 ROIs there.
Yeah, to load it up.
Yeah, so actually I think you need the ROI manager open.
So I can go get that. There we go. And now I can run again.
Let's see if it runs. So I noticed that Java is not a very powerful programming tool, and small things like making very small the windows or minimizing them makes faster the running time. Oh my God, that's really slow in your computer.
Yeah.
So let me run it in mine.
Okay, I'll switch to your
So
screen.
basically, I got this one. Make them very small for you to see something, but basically, so you can save this. One to select me, and then ROI to stack.
Oh yeah, look how fast yours is.
Yeah, and I mean it's pretty silly, but the display time that it takes for ImageJ to show you each slide takes takes out from there. Now,
how do I stop my Mac from running?
just hit escape.
Okay.
Yeah.
Perfect. Here we go.
And we will go run it, but I think if you go, let me see, is ImageJ properties?
ImageJ properties?
I don't know. I think I'm going to allow it to go until 100, and then I think I'm going to stop mine. So we will continue the example just with 100. Maybe it's not worth it. No, I'll be patient. Anyhow, sometimes you hit an upper limit of memory, even doing these very simple things like rotating, like copying a set of pixels and rotating. So I'll show you in ImageJ, or you can look in the manual where to change, where to increase memory.
Oh, okay. So I can
of threads.
output.
Yeah, you can. And obviously, it's a trade-off of depending on your machine and how much do you want to allocate, but you can increase some.
And I can switch to my PC, which has a little more processing power. And
fantastic. All of these run better.
Yeah, my Mac is from 2009.
Well, now I'm running everything in Linux in my work.
Oh,
and
yeah.
I hope this was my new machine.
Linux has all sorts of problems. It goes so fast.
Yeah. I'm still enjoying the static part of having a Mac at home. So it's refreshing to see something pretty. But anyhow, now I think I'm going to start learning R. I was thinking that depending on the character of my little baby, maybe it will allow me to learn a little R and Python. That is mostly what is used in my group. Yes, anyhow.
Yeah, see, mine is still going very slow. It might just be because of my see, I minimized mine here, but
yeah, maybe it's the balance of memory. I think we'll check whenever this is done. Right. So Javier, how is your new home going?
We're doing the move from the storage tomorrow, but it's going great. Love it.
Yay! Excellent. Is it bigger or is it smaller?
Vieja house.
So tiny. Hey, and how is
Not that different, you know.
Yeah. Anyhow, I was very happy to hear that you were staying in Cambridge.
Yeah, it's pretty amazing. The year I could have ended in Sacramento, not Sacramento, in Palo Alto or anywhere.
Yeah.
But essentially the next door. So
that's better for everyone. I'm sure that Jen and the kids are very happy with it.
It's definitely
okay. So this thing is done, and basically what we have passed through is to the original image transformed to a new synthetic stack that has this form.
Yeah.
And if you scroll through this, it's pretty satisfying to see that they are basically in horizontal position. So just by correcting by the axis, you have them almost like a cylinder. And you have only two variations. They are in the anterior posterior, the posterior anterior. So if you just go very quickly, I still tend to check quickly for the stacks. Sometimes ImageJ can have errors that go unnoticed. So probably in, I don't know, 1 in 1,000, in 10,000 times maybe, if you are running many other applications in your computer, it can actually stick two different ROIs into the same slice. So careful. All this is open source code. It's pretty good. I think that ImageJ is a fantastic solution. Thank you, NIH. But it's not perfect. So just be aware of that. Don't trust it that much.
Okay.
So this is our new set of images we're going to focus. And basically, I call this have the same of the subtracted image. So we are in 410. And now I'm going to append the suffix posterior anterior alignment, so PA.
So why PA? I thought it was either pay. I thought it could be either way.
It can be either way, but we're going to save this and now correct for the ones that are in the other way.
Ah.
So now we don't need this or this. And we're going, basically, what I find is very satisfying is that this is an incredible simplification of your image. It doesn't look like in young individuals, but when you see how much extra noise there is in the images of the olds, having defined which is your region of interest and aligned into an axis is very satisfying. It's like, okay, I throw away everything that is not interesting. Now this is what I want to measure. So for correcting to the anterior posterior alignment, you will go to the next macro, that is the PA alignment. And basically, this macro has a couple of variations depending whether you want to run the setup for young or for old. But basically, what it does is extremely simple. It draws two rectangles, one there and one there, and which is the having a given threshold. It's not running, right? It's a very low threshold. Hey.
It's supposed to be 200, not 2,000?
Yeah, and I do it because for this particular experiment, for instance, I will use this same macro for the time series in oxidation. So the 470 channel will drop dramatically and could drop to values that are very, very low.
As long as it's not, you work with a 1, really.
Yeah. So basically,
as long as it's not 0, it's just going to measure image. Because you already did the threshold in before.
Exactly. Well, that's a great point that Javier is saying, because this new synthetic stack, all the background is always 0. So it doesn't matter how low is the intensity inside the ROI. Once you move into this new synthetic land, you are safe. Everything is 0 on the background, and it doesn't matter how low is the intensity, and that it will become very important in the analysis of the old individuals. You're safe. So anyhow, this time you use a threshold of 200, and you draw these two squares, and then compare the region that falls into the square, which of the two has a higher degree of circularity. So basically, when you were doing the circularity, Let's run.
I see we have a binary round variable. Yeah?
Exactly. So basically, when I said this, if left end is higher or lower than right end, I'm talking about the variables that I defined here. And this is a value of the table, of a table that will compare in a table the circularity of this one and this one. We'll extract the values assigned to the variables and decide which one is bigger. And then do a guess and said, okay, I think that this one is rounder, so I'm going to keep it that way. If this one is rounder, I'm going to flip it. So let's run this one again, just see how well it works. And again, for young individuals, it's easier. For old individuals, it's more challenging. But let's see how many mistakes it does. So right now, this table that you see flickering is the table that is measuring with the lower threshold which of the two rectangles has a value of circularity that is higher. It's almost halfway. So again, you could, and I really hope that everyone that takes this code onwards will make it more elegant. You could, for instance, avoid displaying the table, I think. And I was choosing doing it, I don't remember why, but there are many steps in this code that can be ignored or making things more efficient. And I didn't spend the time to optimize it. Once it was working and I had a set of data for the paper, I wanted to use exactly the same pipeline without variations.
Makes sense.
Curious. We have a log. I'm surprised. Usually we don't have this. So let's look to the result. Hey, I have a log because it stopped at 393.09. That's weird. Huh. So let's say that we're going to try to...
So why do you do I equals 1?
Wow, that's
why do you start
weird.
with I equals 1? Why don't you start with 0 and just I is less than infinite?
In Java, I think we have the lower, no, not in Java, in ImageJ, the lower value we have for a slice is 1.
Oh, I thought we had in our previous macros, I thought we had values that were 0.
But for the number of slices, I don't think so.
The 0 was for the pixel values. I went from 0 to 193. Is that what you were thinking?
Well,
I
like,
just
like if I look up at my subtract mode macro, it starts at I equals 0 and goes to I is less than infinite.
huh. I equals 0.
Yeah, if you go up to the subtract mode code.
Wait
Like
a
the
second,
actual
that I was not paying attention. I don't understand why this log is happening. Very weird. So sorry, I got distracted because this thing got stopped in 309. And as you can see, let's go through the beginning of the stack. So it worked stellarly well for the first how many worms? No. So again, all this pipeline was optimized for, so it made one mistake in 246. And you can guess why. Basically, you have, I see it. Yeah.
So why does our code say slice 309?
I just changed it right now because
Okay.
I was pissed off with stopping it. So basically, it had very partial information, and this doesn't sound very round or circular. However, if you move this square, this might be more circular. So that's what I mean. This little individual has this type of crunch in the pharynx that is not rare in all the individuals. So this is the type, this is why I have these two lines, one for normal and one for all, because the boundaries of the squares allows you to play with, to have that flexibility. But right now we don't want to rerun this with new parameters. We just want to flip this particular slice.
Okay.
So I just run the flip slice mode.
Voila.
And check that, and then continue. And I think it will be until nobody's beeping actually. Okay, so we arrived to 309, and look to this. This is one of the aberrations that I can, sorry, is, well, I'm really surprised. I mean, these type of things do not happen that often. So for some reason, maybe I was playing with, no, I was not playing with other applications. I don't know why, but this macro decided to abort at this point. But look what it did. It just, no, it was the previous macro actually. So the ROI 309 was not well pasted, and then you have the rest of the stack is normal. But you have one aberrant image in 309. So when I said draw one square here and one in the other end, the one of the other end was empty.
Oh, okay. So how do we fix it now?
So I would just forget about this stack. Sorry, you are aberrant. And go back to the initial stack. And I am very happy that it happened online. This is very rare that happens. It's another case when I told you that sometimes it will paste two images and with the same in the same slides. Oh my God, what is all this?
You see, mine looks fine on my screen now. It just finished?
The 309, do you mean?
Yeah, here, I'll share my screen.
Yeah, I would love to. Let me go back. Yes. 309 looks awesome.
Yeah, it just finished.
And if you go to the rest of the stack, you have the PA alignment okay?
No, I haven't done it yet. I haven't done PA alignment yet.
Okay, let's run it in your computer.
Oh, look, it's going fast now, too.
This is not fast, Julian. But in principle, well, what you see is basically it makes very little mistakes, and the majority of the mistakes it does, this macro, is justified because basically there is a pharynx that is hyper-contracted, or like in a crunch. So while this finishes running, basically I want to check. Okay, it's 9:25. I think we'll have to leave the profile for tomorrow, the definition of the profile.
So I'll work on this. And,
can we do tomorrow in the afternoon? Because I've been moving in the morning.
Yes, we absolutely can.
Okay, this is great.
So just to finish, before finishing today, I will love you, Julian, to do another thing whenever this is done.
Okay. And the measurement, right? Oh, I'm sorry. Go ahead.
Yeah, what I would like you to do is to, right now we're analyzing the 410 channel image. So I would like you with the 470 image and this ROI manager window to measure the 470 image and save that table. So that is going to give you the table for the tissue for 410 and 470.
Okay, so do the same thing that we just did, but for the 470.
Exactly. Anti-producing this new stack. So if you go to this stack, yeah, I will save it again with the name of the previous stack plus the PI. Once you check that all the pharynxes are actually aligned in this orientation, posterior anterior, so basically arrive to the same point with the 470 data. Hey, that one.
This one. So, let's see.
Yes, right. Okay. So produce exactly the same stack with 470 and then create the ratio image between 410 and 470.
Of
And
the
tomorrow
ROI
we
stack
will,
ones?
yeah. So basically you will have to save this with the name of the previous file plus the PI, and the same for the 470, and then go to the image calculator, divide 410 over 470.
And what do I name that one?
That one you will name PI RI, ratio image of the PI stacks.
All right, so this one is 410, and I'm going to name it PA.
Yeah. Sorry, did you raise the 410? No. Can you show me the whole name of that one?
I just did a different. Yeah, this is good, I think.
Okay, because I thought I didn't see the name there. Save as.
Okay, here's my 410. And here's this one.
No, wait. Go to the end of that file name.
This is the normal one, and this is the PA one.
So basically, look, that PI has not the 410 before the PI. So I'm going to share my window. Basically, I don't have it now. Okay. But basically what you want to have is this name. So something that finishes in all training _ 410 _ PI.
Now
So
I have that.
Exactly, right. So then at the end, when you do the same with the 470, you will have the 470 PI. And then you will have a new one that is the ratio image of the align and posterior anterior corrected pharynxes. And we'll start tomorrow at that point.
Sounds good. And I did the categorization of the old ratio image. Do you want to compare that at some point, or?
Absolutely, of course. That ranking was something missing today. So let's do that also tomorrow with the ranking. I can have a look. Let's do the following. Javier, could you spend a few minutes categorizing those movements of the ratio image? So tomorrow what we can do
it now because my computer can't do it.
Can't?
I have an issue with my computer. I'm using like a really old laptop, and I've been trying to get a new laptop that can. This has XP, and it's a disaster.
Javier, I have a question. The computer you had, some of yourself, the one you made, the supercomputer you have at home.
That's at home.
Why is it home?
Because that's a home computer. But I'm gonna make for the lab something equally better or best.
And you will put it together yourself.
It's good to put together computers. It had 32 gigs of RAM. It's good. Cheap.
Love that attitude. Okay, let me stop.
Northeastern gives me a lot of trouble. Anyway, it's a long story.
So what I propose with the ranking is that actually each of us have an independent scoring of the same data.
Yeah.
If you can do it at home,
I might not be able to do it for this one, but at least we can take the difference between you and Julian and see if it adds up to 0. The
No,
square
no, you
difference.
need at least 3. N equals 3 is the minimum
Yeah.
for anything.
Let's see.
Okay.
I'm gonna see if I can. I might be able to sneak it in tonight. That would be a good thing.
So should I
Good.
put my rankings into an Excel file? Right now they're just text.
It's
No, I
fine.
think the text is fine. Yeah, we like text. We will open them in Jump and see which are the differences.
Okay, I have homework for tonight.
Yay! Awesome. Very good. So tomorrow, basically, we'll see what happens with the ratio image of the align and shift parents.
Yeah.
And we will do the last step of the image processing in ImageJ, that is the definition of the profile. That is geometrically pretty trivial, but actually is the one that takes a lot of juice out of for the analysis in MATLAB and then more complicated analysis that Javier is the wizard for. So we'll focus in profiles tomorrow, basically. And probably instead of jumping into MATLAB straight, because we still have Tuesday and Wednesday, what I would like is, by the end of tomorrow, have a look of the challenges of the old worms after drawing the profile.
Because that's really what we want to be able to do, is to analyze the old worm data, and there were some issues about segmenting those images.
Right. So, Julian, we need you to be courageous.
Yes.
Because basically, the information of any image from old worms, I mean, it's not going to be trivial images, no matter what type of optimization you make. But it's really intellectually a very worthy question, and any research based on aging really needs to have this type of stubbornness of like, okay, these experiments are hard, but are worth enough to do. So we'll see. How do you feel with all the old worms? And
I'll make sure to train Julian in the aesthetics of science, how to keep track of the big picture where you're doing something ridiculously boring, like making sure that this animal is segmented properly and do it on time, commitment and love.
Well, and the thing is, doesn't matter which type of project you hit. At some point, you have this type of bottlenecks that are extremely boring in science. In the most exciting question.
Exactly. Can I say blood ligation of ER localized sensor?
Exactly. And now that I'm working with a lot of people that have like just these sequencings over a night. We have like a next and high next sequencers in the unit, and it's like, I mean, their borings are very boring, and even more boring than image analysis. It's like, oh my god. And you throw like 13,000 euros in one night, and it's like endless. I mean, the amount of boring things in science is pretty huge, which means that whatever you do something meaningful, it will be so meaningful to you that is the more delightful thing. Just a motivation talk. Okay, with this
so same time tomorrow.
Depressive side view, let's meet at 8 tomorrow.
Same time.
Awesome. Yay. Goodbye, everyone.
Bye.
Have a good afternoon.